Hi everyone, I wanted to offer a supplementary explanation on how to calculate the sine and cosine values for a 60-degree angle. I'm going to use a very similar approach to the one that we utilized in class and can also be found in the textbook for finding the sine and the cosine values for 30 degrees. First off, kind of a no-brainer, but let's start off simple. Recall that the angle in between the x-axis and the y-axis is 90 degrees. That being said, I know then that this angle here that I'm highlighting is 30 degrees. So in order to kind of push this argument forward and in order to help me determine and calculate the sine and the cosine for 60 degrees, I'm actually going to choose to push this angle out by another 30 degrees. So essentially what I'm saying here is that I've created a 60-degree angle. Another thing to note here as I continue to construct this triangle is that what I'm highlighting in green is a radius, as that one as well. So recall that since both of those are radii, they are the same measure. If I were to complete my drawing of my triangle, that means what I'm about to highlight in pink are going to be two angles that are congruent to each other. Okay, so in other words, they are the same. So to continue to develop this argument, remember that the sum of the three angles inside a triangle is 180 degrees. I also am going to note the 60-degree angle that I initially created. So this leaves me with 120 degrees left over. Now, since I do have 120 degrees left over, and the other two angles inside this triangle are congruent or the same, all that I need to do is break this in half. So in other words, each of these angle measurements is also 60 degrees. So what I've gone ahead and created is an equilateral triangle here. This means then I can basically push my argument further. So if I know that this side is a radius, and we'll call it r, and this side is a radius, we will also call this r, I can go ahead and find out a little bit more information about the third side. So before I dig any deeper, so from starting at the y-axis going out to the point that touches the circle, this is some mystery point xy. But this is really the horizontal distance that we moved away from the origin. So we're going to call this x. Okay. Basically, this x value is represented here. This is the horizontal distance that I moved away from the axis to get to that point that's resting on the circle. That means that this side on the left must also be x. Since this is an equilateral triangle, this must mean that 2x, since that's what I do have here, is equivalent to saying it's equal to a radius. Now I'm going to go ahead and do a little bit of a modification here, and I'm going to actually say that this is x is equal to r divided by 2. Okay, so what I actually have here is I can actually push this a little bit further. So let's say that we look at cosine, because we know that cosine of theta is equal to x divided by r. I'm going to go ahead and make a connection here. I've defined x to be r over 2. Well, there's nothing to say that I can't substitute in. So what I'm saying here is that the cosine of 60 degrees is going to be equal to r over 2 divided by r. So we have a complex fraction that we can go ahead and clean up. So this is going to actually be r divided by 2 divided by r, and then we can also use what we know about dividing with fractions. I'm going to go ahead and skip the first value, take the reciprocal of the second, and I've created multiplication. In doing this, I've learned that the cosine of 60 degrees is 1/2. Okay, so at this point it's actually smooth sailing. if I know what the cosine of 60 degrees is, I can actually snowball this into finding out what the sine of 60 degree is simply by working with the Pythagorean identity. Recall that the Pythagorean identity states the following. We know that the cosine squared of theta plus the sine squared of theta is equal to 1. Also recall that an identity means that we can drop anything in for theta and we will get true statements. So I can go ahead and jazz this up a little bit by saying the cosine squared of 60 degrees plus the sine squared of 60 degrees is equal to 1. So all that I've done here is I've done a substitution. Instead of working with the generic theta, I'm going to explicitly find out what the sine of 60 degrees is. So we'll go ahead and we'll continue to make some modifications. I know that the cosine of 60 degrees is the same thing as 1/2. So instead of cosine 60 degrees squared, I'm going to do 1/2 squared plus the sine of 60 degrees is equal to 1. Squaring this, we get a value of 1/4. Subtract 1/4 from both sides. This gives us, oops, I'm missing my squareds there. Hopefully you caught that. Taking care of the subtraction, I get the sine of 60 degrees squared is equal to 3/4. So what's standing in our way now is that square. So I'm going to go ahead and square root both sides. Let me move this up so we have some more room. This is going to give me the sine of 60 degrees, which is what I want to find, is going to be equal to, we can break this up into the square root of 3 over the square root of 4, or square root of 3 over 2. So we've actually arrived at our goal here. We know that the cosine of 60 degrees is 1/2, and we see that the sine of 60 degrees comes out to square root 3 over 2. Okay, so there you have it. This, again, was a similar explanation that we had used to find the cosine and the sine of 30 degrees. I hope this explanation was helpful. If you do have any other questions, please let me know.